Hello, everyone. Thank you very much for joining today for the webinar of the series introducing the research priority teams of the ICARP IV process. My name is Nina. I work with the European Polar Board, and I'm here with the co-chairs of the ICARP IV Research Priority Team 1, the role of the Arctic in the global system. Kabir Rasouli from Desert Research Institute in the US, and Xiangdong Zhang from North Carolina State University in the US. So just a couple of words about the ICARP IV process. The International Arctic Science Committee, or IASC, in cooperation with many partners worldwide, is coordinating a multi-year planning process for the 4th International Conference on Arctic Research Planning. It lasts from 2022 to 2026 and engages Arctic researchers, indigenous peoples, policymakers, residents, and stakeholders from around the world to discuss the state of Arctic science and the place that Arctic occupies in global affairs and systems. So between 2024 and 2025, the ICARP IV International Steering Committee convened 7 research priority teams that will work with the input provided through the ICARP IV community engagement process to define the knowledge gaps and research priorities for the topic area, and to identify and suggest opportunities to exchange synergies across existing and potential research plans. So we are happy, the European Polar Board is very happy to organize this webinar series for the research priority teams. And we will start with the presentation from our co-chairs. And there is also a Q&A box available for you at any time. Please don't hesitate to use it for your comments and questions, and we'll take them afterwards. Okay, so I'm giving the floor to our co-chairs.
Thank you, Nina. I think Xiangdong will start and I will follow.
Okay. So good morning, good afternoon, and good evening, everyone. My name is Xiangdong Zhang from North Carolina State University. So today we are going to give an introduction about our research priority team, Team 1. Kabir is also a co-chair. He represents early career scientists. Can you guys see my slide?
We can see your slide, but not your camera.
Okay. It's good right now?
Yes.
Okay, good.
Not your video, but the presentation is working, yes.
Okay, okay. Yeah. So this slide contributed by there are a number of team members made a contribution to these slides. So I list the team members' name on these slides. We also have a large number of people who join discussion and communications for preparing these slides. So I did not include those people's name on this page. So as Nina introduced, there is a research priority planning process from 2022 to 2026. So this process is called ICARP IV, this research planning process. So there are 5 phases for this process. The phase 1 is preparing for Archive 4. Phase 2 is seeking community input. So this phase has been going to this year from last year. And the phase 3 is define researcher opportunities. So we're currently in phase 3. So next phase will be consulting on priorities. One major activity is ICARP IV Summit and the ASSW Summit in Boulder next March. So there are a number of science sessions. They are calling submission of abstracts. So the deadline has been extended to October 9th. So if you are interested, please catch this last opportunity to submit your abstracts. So that's important step to get the community engaged. So the last phase is initiating implementation. When we identify research opportunities, so we need to find the avenue to implement them, right? So the avenue is IPY 5, is the 5th International Polar Year. That's scheduled in 2032 and 33. Yeah. So this ICARP IV process will make contributions to developing research, Arctic research themes for IPY 5th. So here you can see the time schedule for preparing the IPY 5. Here in this webinar, I mainly focus on the phase 3, defining research priorities. During this phase, the ICARP IV Steering Committee has established 7 research priority themes since the end of last year. So here is a list of the 7 research priority teams. The team 1 is about the role of the Arctic in the global system. The team 2 focuses on observing, reconstructing, and predicting future climate dynamics and the ecosystem responses. So the team 3, the topic is about understanding the vulnerability and the resilience of Arctic environments and societies and supporting sustainable development. The team 4 is working on Arctic research cooperation and diplomacy. The team 5 is working on coal production and indigenous-led methodologies. And team 6 preparing present and future generations education, outreach, communication, and capacity and networking. Team 7 is about the technology infrastructure, logistics, and services. So all the teams will work with the input from ICARP IV community engagement process to define the knowledge gap and the research priorities for the next decade for each research topic listed here. And then identify and suggest opportunities to enhance the synergies that might exist across the existing research plans, or where there is potential for formalizing new alliance and collaborative partnership. So here I would like to mainly introduce the team 1, the role of the Arctic in the global system. So in our teams, the team members covering the broad area about physical processes and chemical processes and biology, biogeochemical processes, including the atmosphere dynamics chemistry, meteorology, physical and biogeochemical oceanography, CIS, physical and biogeochemical terrestrial processes, and also Greenland ice sheet and social impacts. So we have 34 team members from 12 countries with different career levels from senior scientists to early career scientists. So like we have a Kabir represent early career scientists. This is important for these processes and for the continuation and the sustainability of science research into next generation, right? Okay. We also planning to add indigenous member to extensively engage in indigenous knowledge. So So we can see from this diagram, the team 1 also strongly collaborative and interact with other research teams. So team 1 provide a foundational solid science knowledge to this planning process and to other research priority teams. We are also going to get feedback from other research teams. And then finally, we are going to provide our results about research priority and for the next decade. We are going to provide our recommendation. About our team, we started from March this year. So we had a kickoff workshop in UK. This is the agenda of the workshop. So during this workshop, we invite eight scientists to give presentations. So those presentations inform the community what we are working on and what we are discussing about science. So those presentations also raise the number of key scientific questions. Thus, it stimulates discussions among the team members and also engaging the broader communities. So those presentations and scientific questions raised by those presentations also initiated brainstorming and the teamwork for conducting the planned research tasks. So the objectives of our team 1 is to address research priorities and their implementation, like what I mentioned earlier, regarding the topic about the role of the Arctic in the global system. So here on this slide, I list a number of examples. It does not cover, those examples cannot cover everything. This is just as initial examples, give you a flavor what we are thinking about and what we are working on. For example, the first example is the need for further scientific understanding of the role of Arctic in the global system, from past time to the present day and into the future. We are not only focused on present day, so we cover the entire time spectrum and from a past to into the future. The other example is about teleconnection pattern. This teleconnection pattern can be triggered and excited from Arctic or lower latitudes. That's a link Arctic and lower latitudes. So it's major, large-scale dynamic processes. So other example is the impacts of a rapid changing Arctic on stream events, both locally within the Arctic and remotely in the mid latitudes and the lower latitudes. So this is a really hot topic during recent 10 years. Yeah. The next one will be the temporal and the spatial distribution of precipitation, permafrost soil. And we also have members working on short-lived climate forces, like, for example, like the seesaw, aerosol, and black carbon. So that's the important forcing factors for agency for the global warming effects. The final example is a global consequence. So this is related to social impacts on the context of Arctic and global climate linkage. To achieve those objectives, so we have a number of research tasks. The first one is reviewing and analyze community input. This is really community-based planning process. So there it's important to get the entire community engaged. So when we get the input from the broader communities, so we are going to review and analyze those input. And then we define knowledge gaps and the research priorities for the topic area. So our topic area is the role of Arctic in the global system. And then we are going to drafting recommendations on how to address those knowledge gaps and the research priorities. And the next step, we are going to consulting on preliminary results from other research priority teams online or during the ICARP IV summit, as I mentioned earlier, in next March. And then we are going to finalize the results of recommendations on science and implementation plans. So we have a deadline to submit our recommendation this October 2025. So beyond that, we are going to continually working with the ICARP IV steering committee to refine the research priorities and recommendations. That will be contribute to the preparation of research themes for IPY 5. That's planned for 2032 and 33. Yeah. To contact those research tasks, we organize 5 research themes. Yeah, from what I have introduced here, you can see our team covers very broad area of Earth system, both for Arctic and the global system, right? So during the workshop, we had discussion how to proceed to contact our research tasks. So we define 5 research themes, and I also tentatively identify the lead scientists for each theme. The first research theme is improvement of and integration between observations and models. Yeah, this is very fundamental. So observations provide a basis for data analysis and for monitoring. Models provide the very useful tool to understanding those processes, right? And the second theme is about Earth system linkage and the feedbacks between the Arctic and the lower latitudes. Actually, it's also including feedbacks within the Arctic. Yeah. The third one is the attributions of Arctic changes. So as we know, the Arctic climate has been changed dramatically, right? So Arctic warming has been amplified significantly. So we need to understand the attributions of those changes. So the first one is about terrestrial system. So look at the role of Arctic terrestrial system in global change. The fifth is about social economic implications and the consequences and the global collaboration. To give some flavors to the community about what we are thinking, what we are working on at this initial stage. So we are still at the initial stage. Everything are under development with the time. So here in the following slides, I'm going to give examples, and Kabir also going to present examples about terrestrial and social impacts. So the first case is from research theme 1. It's about the observations. Okay, from a left column we can see the global observational system for the up air observation how to get vertical structures of atmosphere. So through sounding observations. So in this organization of network, we can see from the first panel, there are about 30 to 40 reference observing systems, observing stations. Those reference observations provide long-term high-quality observation to monitor long-term changes of the atmosphere system. So the middle panel shows the baseline observation system. There's a more larger number of observation stations. So to measure vertical structures of atmosphere. So the third one shows integrated observation, upper air observational archive. So from those three panels, the three figures we can see, there's a big gap over the Central Arctic, right? So there is a lack of vertical structure observations over the Arctic, especially during the winter time, because it's really climate harsh area. It's really hard to access to the Central Arctic to do measurements, right? So this brings a lot of difficulties to do studies, right? To analyze climate changes, to understand the physical processes over the Central Arctic. And also it brings difficult to verify the models. As we know, the model has bigger bias over the Arctic, right? So Michael provides some thoughts, provides some ideas how to improve observations of our Arctic system and how to developing, sustaining Arctic observation system. So this is his idea. The first one, maybe we can follow the design and the organization of a global observation system. For example, we can have a coordinated, enhanced field observation over the Central Arctic using icebreaker. So that can provide a reference observation system that provide high quality and long-term in the future, for the future as long-term observations of Arctic atmosphere. And then based on the land surface weather stations and the satellite observation system, so we may develop a baseline observation system that's similar to the Guam, is a baseline observation, a global baseline observation system. Because the Arctic observations can be still very limited, so it's still hard to get high resolution, spatially and temporally well covered observations. So we need to combine the modeling system, data simulation system, and all available observation data to fill out the gap for the Arctic. So that can be, we can develop, for example, we can develop the high resolution reanalysis covering the entire Arctic system. Because as we know, the satellite measurements, satellite observation has a bigger bias over the polar area. So it's from the nature, there is a low the solar angle, right, for the satellite observation. So we really need to improve the satellite observation. This is for the next decade. We also need to improve models because model has bias over the Arctic simulation and projection. So some processes cannot be realistically represented. So we hope to combine to improve the observation system, to get more data, to get improved understanding of a physical process, and then improve the model physical process that can feed back to the observational data to develop an integrated model observational data sets. Yeah. The other thing is improve the data simulation system for the Arctic. So just now I mentioned the model improvements, right? Combination integration between the observation and the modeling system. So what's a critical elements for the model improvements? So as we know currently, the CMIP type of models is state-of-the-art climate models, Earth system models, mainly have the spatial resolution at the order of 100 kilometers, but many physical processes has finer scale resolution, right? For example, I show the examples here, the snow process. If there's a blowing snow and the drifting snows, snowpack structures or something like that, or snow deformation, so we can see there's the high resolution physical processes involved. So those processes important to influence the surface and the atmosphere interaction, including the cloud formation and the cloud radiation interaction and feedbacks. So when looking at the stream events, that's really important for for society for mitigation of climate changes. So many stream events occur at the final scales. So for example, on this diagram, it lists the spectrum of resolutions. So we really need to understand the final scale physical processes. For example, at a 1 kilometer spatial scale. So to improve the model simulations or representations of those high resolution physical process, we really needed to combine or integrate the improved high resolution observations with the model development effort. So yeah, this is what we have discussed, what we are thinking about. This is slides from Priscilla Mooney. Yeah. So there are also a number of examples about Thing 2. So one is about a cutting-edge research topic during recent 10 years. So, Arctic temperature increase has been substantially amplified. So that has changed the mean meridional temperature gradients, and that's an important forcing factor for atmosphere circulation. So there is a hypothesis the amplified warming may influence the larger scale the atmosphere circulation dynamics in the mid latitude and the lower latitudes that may cause extreme events in the lower latitudes impact the society. Right. For example, in this year, at the beginning of this year, the Montana got extreme cold events, like what's showing on the left panel. There's also increased frequency of heat waves in the mid latitude. So it's nature to look at how Arctic warming to influence mid latitude stream events, right? So IPCC ER6 provide the summary water dynamic processes can link Arctic warming and the mid latitude atmosphere circulation dynamics, and then to cause stream events. For example, during wintertime, the Arctic warming may weaken the polar stratosphere, polar vortex. So that may cause changes of storm tracks and cause the amplitude of stationary waves and the jet streams. During summer, even there is no large-scale stratosphere polar vortex. The warming of the Arctic may still influence the position and the intensity of storm tracks in the mid latitude. and also stationary Rasouli waves, and also influence the shifting seasonal migration of jet streams. There has been a largely increased publications about this process during recent 10 years. But unfortunately, there is no agreement that has been reached because the entire dynamic system is so complex. The global warming effects not only influence Arctic, it also can independently influence mid-latitude. There's also the large signals from nature variability of the very dynamic Earth system. So it's not easy to isolate or to distinguish the roles or the contributions from Arctic warming and from mid-latitude warming, low-latitude warming forcing, and also nature variability. So the entire committee has been continuing working on this topic to try to improve understanding of this Arctic mid-latitude or low-latitude linkages. So the one effort for this research topic is intercomparison of model simulations. So there is the polar amplification intercomparison project proposed a few years ago on the CMIP6. It's endorsed by CMIP6. They try to identify the effects of amplified Arctic warming on the lower latitudes. But unfortunately, through this modern effort, there's a summary showing on the left-hand side. We can see the model response is very small compared to the observation. When take a further look at the individual model simulations and the individual model ensemble runs, we found there's a bigger problems between model simulation and the observations. Only the single model, only a selected single models or single ensemble runs can capture some observed linkage between Arctic and the mid-latitude linkage processes. When looking at a larger model ensemble mean, so most models cannot deliver the message about this Arctic mid-latitude linkage. So this is a big challenge for this research topic on the modeling part. So a group of people is currently propose PA-MAP, the intercomparison project phase 2, to continue in this study. So as we know currently, so far, there's a large number of studies focused on large-scale dynamic processes, but the stream events occur at small scales, at synoptic scale and mesoscales. There's a strong multi-scale interactions. For example, on this slide, we show the synoptic scale cyclone changes during last 70 years and in the future model projected climate. So on the left-hand side panel, we can see the Arctic cyclone activity has been enhanced during the last 70 years, 7 decades. So that caused the increase of frequency of stream events over within the Arctic. At the same time, some studies suggest that there is a weakening of synoptic cyclone activities in the mid-latitudes. But the research results from different studies are also inconsistent. So when looking into the future, like what's showing on the right panel, this shows that in the future time, from model projections, there will be weakening of cyclone activity during summer in the mid latitudes. But these multi-scale interactions, for example, between Arctic large scale circulation dynamics and synoptic scale weather systems, is still unclear. So this is really important topic to try to understand what really causes the occurrence of the stream events or the changes of frequency of stream events. Yeah, as we know, not only about the stream events in the topic of Arctic and lower latitude linkage, we're looking at the thermodynamics and the dynamics between Arctic and the lower latitudes. We can see there is a changes of heat transport in both atmosphere and the ocean that influence energy budget over the Arctic and the energy budget in the lower latitudes. That's provide a very fundamental. Those are very fundamental physical processes to understand the changes of Arctic system and the changes of a global system. The upper panel shows the example. It indicate the changes of atmosphere circulation during last several decades. So those changes of large scale circulation can enhance atmosphere moisture transport into the Arctic and enhance heat transport into the Arctic. So that can cause the changes of Arctic surface energy budget, even with the increase of moisture that can enhance, intensify cloud and the radiation feedback, right? So that's the changes of large scale circulation can also increase wind stress towards the Central Arctic. Because the ocean circulation is strongly driven by wind stress. So from observations and from model simulations, there's an increase the ocean heat transport into the Arctic, like what we are showing here at the bottom. So when looking at the Atlantic, the ocean heat transport into Arctic, that's a major heat source for the Arctic Ocean. So we can see there's the Atlantic water layer has been the increased and extent has been increased in the current time and in the future time. The heat flux from Atlantic from water from an increased the warm temperature in the ocean layer also can be increased in the future time. Yeah, it's an ocean. It's a heat transport between Arctic and the lower latitudes. Under this research theme, the number of team members working on chemical by geochemical processes. So they're working on short-lived climate forces, such as the seesaw, aerosol, black carbon. So these processes can also be very complicated. There's a local the sources and there's also remote sources. So during our workshop and during our the monthly meeting, we have a lot of discussions about this. We mainly focus on, for example, we emphasize the interactions between dynamical processes and chemical processes. There's a major lack in the knowledge and in the research efforts on these interactions. Yeah. For example, in the high latitudes, in the low latitudes, there's the increase of frequency of wildfires that creates emissions of aerosols, right? So those aerosols can be transported into the Arctic, but currently there's still there's still need for research effort to improve understanding how this long-range transport of aerosol into the Arctic and influence Arctic climate. So because Arctic climate has been changed dramatically, not only for atmosphere, not only for ocean, there's also dramatic changes in the sea ice and ocean biology and land surface processes. So there's a strong interactions between those physical processes and chemical processes. So we still need to make a big effort to understand those interactive and feedback process. Yeah. The other example is about blowing snow. The blowing snow is really draw a lot of attention during recent couple of years. So it's missing in the current in the state of the art or the system models. So with the increase of, for example, with the increase of frequency of strong cyclone system or anti-cyclone system over the Arctic, there will be increase of the strong wind that can increase the frequency intensity of a blowing snow. So that can cause it. The blowing snow can drift the sea soil aerosol into the atmosphere and the moisture into the atmosphere that influence low level the clouds, right? That can influence the cloud radiation feedback, and then that contributes to the Arctic warming amplification. This is really a big missing part in the study and in the Earth system model. Yeah, this is some examples of SIM2. About SIM3 is about attribution. As we know, the climate change has been occurring for the entire Earth system. For example, the atmosphere has been warmed in much faster than global average. Right? The ocean temperature has been increased also. There's a dramatic decrease of sea ice extent and thickness. There is a shrinking of Greenland ice sheet. There's also intensify hydrologic cycle and the changes of biogeochemical process, vegetation permafrost, the increased number of forest fire. Right? There's a systematic changes of Arctic for the long term. Okay, when looking at the long term, the historical records, and when looking at a projected future climate state. So the challenging question is, what's attribution for that? Especially there's a external forces, there's an internal feedback process, interactive processes. So there's a natural variability. So all of those processes and forces interact dramatically. So yeah, we need to identify, we need to understand the sources and attributions of these systematic changes. Yeah. Okay, I think I stop here, and Kabir is going to mainly talk about SIM4, about terrestrial system and social impacts. Yeah. Okay, Kabir, could you move
Thank you,
forward to
Xiangdong.
show those slides? Yeah, thanks.
Thank you everyone for joining this webinar. It's a pleasure to be here. So far we talked about atmosphere and ocean. So I will focus a little bit on terrestrial processes, mainly changes in permafrost and hydrological processes, glaciers in the Arctic, and how it is affecting the mid-latitude in different aspects. So you can see here over the left-hand side map, this is basically showing and the areas that covered by permafrost, continuous permafrost, discontinuous permafrost, or sporadic permafrost. So around the Arctic Ocean. Over the last couple of decades, we have seen dramatic changes in both permafrost area and how it has been evolved in terms of thawing. You can see that from 1993 in this particular area, how thawing permafrost is basically reshaping the landscape. So it is affecting not only hydrology but also carbon cycle. The right top panel is showing the soil organic content, organic carbon content. So you can see that this area is rich in carbon with thawing. Permafrost basically this organic carbon is decomposed and providing a positive feedback to Arctic warming. From hydrological perspective, these changes in permafrost and climate change in general causing changes in discharges in the rivers. You can see in the annual discharge of I think a couple of rivers that releasing water to Arctic River has increased over the last couple of decades, which basically changes the water or whether salinity of the water in the Arctic Ocean. You can see in the middle panel that river water tracers fractions, basically showing that how much water in the ocean comes from the rivers. So it has been increased mostly from the Russian Arctic side, but in general, the increase from rivers discharge into the Arctic Ocean has increased the or changed the salinity of the Arctic Ocean. And also evapotranspiration is also changing. You can see that the trends in evapotranspirations from the areas nearby the Arctic Ocean is increased in last couple of decades. So in general, thawing is increasing terrestrial water storage, increases water discharge into the ocean, and evapotranspiration, basically increasing the likelihood of convective storms in the not only in the Arctic regions but also in the mid latitudes. So providing another positive feedback to Arctic warming. Next slide, please. Yeah, other than permafrost, we see, as Xiangdong mentioned, we see more frequent wildfires in northern latitudes. I'm showing here the fires in 2023 in Canada, mostly in northern latitudes, but not all happening in Arctic regions, but in general, starting from north to the south. Can see that 18.5 million hectares burned in just 1 year, which is basically 5% of Canadian forests, which produced lots of carbon emission to the atmosphere. In just one single year, it was like 3 times the annual emission from the entire country. So that's how much wildfire can provide another positive feedback into climate warming. Of course, it causes damages and death toll every year and evacuations. So that's one one thing. The other thing that is changing the landscape of the Arctic or mid-latitudes is the changes in the vegetation. We know that we have shrubs or tundra expansion toward northern latitudes as well as toward higher elevations, which is changing again snow processes, as Xiangdong mentioned in one of the themes. So blowing snow is controlled by how tall the shrubs or tundras are. So any changes can change the land atmosphere interaction. Here I'm showing just snow over different elevations in one of the research basins that we have observations. For present climate, you can see that in say in April we have the highest snow on the ground. If you click Xiangdong, please. So under climate change scenario, you can see that it will be decreased, not only the peak snow, but also the duration of the snow on the ground will be decreased. But it is interesting to see that green line. Sorry, go back. Yeah, green line is when we have sharp tundra expansion or changes in the vegetation. It is basically increasing the peak snow as well as increasing the length of snow on the ground. So it is in the opposite direction of climate change. So we saw that early changes in shrubs or vegetation or terrestrial changes can either offset the impact of climate change in that areas or enhance the climate change impacts. Here in the northern latitudes and higher elevations, we saw that sharp tundra expansion effect on snow can offset the impact of climate change. That's not the case in lower elevations or lower latitudes. Next slide, please. Also, here I'm showing how moving from north to south, linking between Arctic or subarctic towards mid-latitudes, how annual runoff is changing with changes in precipitation. Remember, we said that evapotranspiration is causing more moisture in the atmosphere, and as a result, we expect more precipitation in northern latitudes. So how this increase in precipitation can change the runoff on the ground. So moving from north to south, we see that increased precipitation can increase runoff more toward mid-latitude stations. Next, please. In terms of snow, again, moving from north to the south, increased air temperatures can change the snow dynamics. As a result, again, increased warming can decrease snowpack more in mid-latitudes than in the north. So in general, the impact is more in the mid-latitudes than in the Arctic for snow hydrology. So it can be due to the milder climates in mid-latitudes, but in general, we see more impacts in mid-latitudes than in the Arctic itself. So what happens in the Arctic doesn't stay in the Arctic, and it has impact on mid-latitudes. Next slide, please. So also we see tremendous changes in glaciers and also ice sheet, Greenland ice sheet. So we would like to see how will Greenland ice sheet evolve, and what does it mean in terms of melt or mass balance loss under climate change. What will be the mass loss under climate change, and how this will impact the sea level rising. So you can see that most of the climate models and scenarios showing surface mass balance declining by the end of century, and also shrinking out the ice sheet from the coast, so it can be up to 5 meters per year. And projections are the same, so we can see that we see retreated 25 kilometers by the end of century. Lower panel again showing a mass balance of Greenland ice sheet, and clearly showing that both a surface mass balance and in general mass balance and discharge are increasing, which mass balance is decreasing, but discharge is increasing, which is causing sea level rise up to 160 millimeters by the end of century. So it has a tremendous impact on water levels in the seas and oceans around. Next slide, please. So the next theme of our work is basically basically link between science and policy at the interface of regional and global scales. And we found that basically some of our team members working on that to answer questions like what research do we need to resolve the challenges, not only in the Arctic, but also globally, and how these Arctic challenges and solutions can be related, not between Arctic and global aspects, and how does Arctic region governance affect the global governance at different levels. And also, we would like to prioritize governance research questions, and under so many changes in the climate indices and tipping points that we see under climate change. And also, we would like to see what research priorities can be identified from the indigenous perspectives that they have already prioritized the research that needs to be done in their area. So we don't want to create the wheel. So we will focus, or we will use those statements and research priorities and further develop based on them. And lastly, what kind of synergies with existing research plans and new collaborative partnership we can facilitate progress in research in global, regional, socioeconomic dynamics. So in general, we will identify the gaps between, identities like from terrestrial, ocean, and atmosphere and ice, and we will focus on governance and security as well, and how we can identify challenges and solutions at both Arctic and global scales. So that's it for last two priorities. I don't know if we are going about the time that we have. Xiangdong, you wanna take over to last couple of slides? You're muted.
Thank you, Kabir, for introduce the SIM 4 and the SIM 5. Like we mentioned earlier, this is a really community effort. So to finish our work and to finish this work for the entire community. So we would like to get engagement of the as large as possible colleagues. For example, here, how to engage into these processes. So here I would like to show some examples. The first one is, okay, for example, the community and any colleagues can, for example, you can organize proposals and conferences and with with the support from different agencies, with the support from International Arctic Science Committee, right? You can get endorsement from ICARP IV also. So here I would like to show the three examples. For example, some years ago, we organized two workshops about Arctic and Mid-Latitude linkage, showing here. From this workshop, the number of colleagues, the team published review papers in Nature Climate Change and Nature Geoscience. So those two papers promoted the research on the topic very much. So that's since the publication of those papers, there's a large number of increase of publications on the topic that help us to identify research knowledge gaps and the research priorities. The other one, for example, we organize Arctic streams workshop in Colorado in 2022 on the support of ISC and several US funding agencies. So we are working on the paper on that right now. So this stream events topic it's become the attractive right now. So there's the increased number of the research efforts on this topic. Yeah. If you have, for example, if you organize a workshops and conferences, if you have white paper and if you have a workshop report, if you can send your product's outcome to our team or through ISC web page, so we are going to review those products and incorporate them into our final results from this team. Yeah. The other example is a national report about Arctic system. Yeah, for example, the ISO publish the report every year, right? So this year, it seems that there's a new report published by ISK this year. For example, the Japanese community and the government publish the Arctic research plan. The US community also publish a research plan. So those research plan identify priority research areas. Those messages, those information are really important input to the ICARP IV planning processes. Yeah. So as an individual, you can also submit your input through the ICARP IV webpage. So you can go to visit those webpage. You can submit your resources, for example, the publications, the papers, reports online. So then each research team or research priority team will collect those information, review those information, analyze those information, and then that will be part of our final products. Yeah. So finally, I would like to mention this Arctic Science Summit Week again. So that will be in next March. There are still the several days before the deadline to submit your abstract. You can find out which science session will be the best fit for your work. So, okay, I am going to finish here. Thank you all for your very much for your attention and for your participants. Okay, if you have any questions, let's know. Okay, Nina.
Hi, yes, thanks a lot for this great presentation and introduction to your research priority team and your work. So we do have a Q&A box, so please, all the participants may leave the questions there or the comments. And you may also raise a hand if you would like to speak out loud, to ask your question out loud. You may also do that. So please raise your hand and we will unmute you, and so you could speak. Yeah, also let us know if you have troubles sending the question or
Yeah, that's one thing I would like to emphasize. What we are showing here, just some examples. So our work is not limited to the examples I'm showing here. So this is really the working process until the next October. So we have a deadline to submit our final results. So yeah, I found a couple of team members here online. So if we miss anything, maybe those colleagues can add if there's anything we're missing here. Okay.
So we do have a question in the Q&A box. Kabir, would you like to take it?
So, I think I'm not sure it is a question, but thanks, Rami. Yeah, of course, it is a very diverse backgrounds, and it is very difficult to really have a synergy among the disciplines, but that's how difficult is the problem. Yeah, thank you, Rami.
Maybe while we are waiting for if anyone else would like to ask a question, I have one. So what are your expectations and your plans for the upcoming meetings and other planned events together with the other RPT co-chairs? So what kind of collaborations or synergies would you like to develop further with the other research priority teams?
We are going to have a co-chairs meeting in Iceland, and at the end of this month, we have the steering committee had interactions with all co-chairs. So we had online discussion. We are going to organize during the meeting in Iceland, each team will introduce their initial results and their plan for the future. And then we are going to have a joint meeting across the different research teams. And then we will have interactions between each team to develop integrated products. So we provide information to other teams, and the other teams provide feedback to us. And then that's very important for develop coherent integrative products. Yeah, like the identification of research priorities and provide recommendations for next decade and also for planning IPY 5. Yeah. So
I just want to add that we have so many areas that overlapping with other teams. For example, indigenous knowledge co-production. We would like to also have um, science policy in linkages in our team, but we will work closely with other research priority teams like Team 5 um, to link this research areas. So I think that's a key meeting to uh, understand what they have done and how we can contribute to each other's research priorities.
Right. Thank you. Right, we have a little bit more time. If there are any questions or comments, so please do let us know.
yeah, it could be too early in US and it could be late in European countries where people get tired. Okay.
That is
Yeah.
true.
Yeah, anyway, there's a long process. There are still the long time to go. So there will be a lot of opportunities, a lot of time to get the input from all colleagues. Yeah. So yeah.
Yes, and please, for all the participants, we left the link to the engagement page of the ICARP IV process website. So
Yeah.
please check it out. As our co-chairs suggested, you may leave the links and the resources and share other information with the RPTs there. So please do engage.
Yeah. Yeah, that's important. Especially, I would like to encourage young scientists to get engaged. So that's important for your career's future. There will be IPY 10 years later, almost 10 years later. So yeah, here in our team, there are a number of early career scientists. Kabir is a representative. If we don't be shy and be brave. If you feel your hesitation to talk with the senior scientists, so we have represented here, so you can talk with the early scientists. Yeah.
All right, then I would like also just to remind you about the upcoming webinars. So we have two more the next week. Kabir, you were saying that you have a lot of topics that you share with the other teams, specifically the RPT5. So if anyone is interested, there is their webinar is on Monday. So please join us for this one as well. And also the RPT3 are presenting their team on the 9th next week. So I guess we could wrap up.
Okay.
Yeah,
good.
I just want to add that if anyone has any question, would like to contact us, I think we have an email at the link that Nina put there for ICARP 4. So let us know if you have any comments, any suggestions. We would be more than happy to take into account.
Yes. Thank you very much, all the participants, and thank you very much, our RPT1 co-chairs, for this great presentation. And yes, see you later.
Thank you, Nina. Yeah. So
Thank you for hosting. Yeah. Thank you, everyone.
Thank you. Bye.
bye.